Okay, now we're going to work on one of the more important problems of the entire semester, trying to hook up two functions so that they hook up in a smooth way. Now, here's the thing. The 2x to 1/3 part, that's just one of our power functions that we made go up and down twice as fast. It's going to be smooth the whole time. It's certainly going to be smooth until I stop drawing it at x equals 4. Y equals mx plus b is a line. That's smooth, right? It's certainly going to be smooth after I start drawing at x equals 4. So to make sure this is continuous and differentiable, the only point I have to worry about is x equals 4. And we're going to have to do two different parts of this. Number one, we're going to have to make sure it's continuous. So I'm just going to put cont for continuous. That's only one thing it can mean. We're going to have to use the definition of continuous, which means that the left-hand limit, and we only have to worry about 4, so 4 minus of f of x, like that, has to be the same as the right-hand limit, so x arrow 4 plus of f of x, and that has to be the same as the height of the dot, which is f of 4. And let's just do each little piece. When I have limit x arrow 4 minus, well, that says you're only plugging in numbers that are smaller than 4. And when x is smaller than 4, we don't have f of x. We've got a formula here. So what I'm going to do for when x is less than 4, I'm going to put in the little formula we have. So this is LIM. I have x arrow 4 minus, and I'm going to put in 2x to the 1/3. Well, I'm supposed to evaluate that limit. What's the first thing we do when we evaluate limits? We try to plug in. So when I take 4 and I double it, I get 8. 8 to the 1/3 is the cube root of 8. That's just 2. So this part here is just 2. Let's do the next piece. When x is bigger than 4, it's not f of x. I have a formula for it. It's just mx plus b. So I'm going to put a little equals here. And this is going to be the limit as x arrow 4 plus of mx plus b. That might feel a little strange, but it's actually very easy because this is just a line. It's continuous, so I can find a limit just by plugging in. What am I plugging in? A 4 wherever I see an x. So what I'm going to get here is just 4m plus b, like that. And in order to be continuous, the left-hand limit has to be the same as the right-hand limit, has to be the same as the height of the dot. Now I'm supposed to plug in 4 according to my formula for my piecewise defined function here. Plugging in 4 just gives me 4m plus b. Now, let's just look at what this means. This says in order to be continuous, 2 has to be 4m plus b. Now, what does that mean? That says when you draw the graph of 2x to the 1/3 and stop at 4, there should be an infinite number of lines that you can draw that start at 4 with all manner of different slopes and such that work. And this condition right here describes all of them, and I would like to actually keep that as a condition. Now, 4m plus b is always equal to 4m plus b, so that doesn't add anything to the condition. The condition I really am worried about is just that piece right there, and I'm going to put that in a different place and come back to it. In most math classes, they'll say, I'm going to store this in the refrigerator, and we'll bring it out later. So I have this little whiteboard down here. I just write down 2 equals 4m plus b, and now we're going to worry about the slopes. Because as we just mentioned, there's an infinite number of lines we can draw there, but there's probably only one that actually makes it smooth. So what we're going to do now is worry about being differentiable, and we're going to have to use some of the information they gave us. Right? In order to be differentiable, they can't just be the same height. The left-hand slope has to be the same as the right-hand slope. For the functions we're looking at, this is the right condition. There are more complicated functions where this is not enough, but for the functions we're looking at, this works. So I want the limit of the left-hand slopes to be the same as the limit of the right-hand slopes. That'll stop it from being jagged. Now I'm going to do the easy side first. The right-hand side is the easy side. Why? Well, because the right-hand side is just mx plus b, so I'm just going to write down here LIM x arrow 4 plus, and I'm going to write down mx plus b because that's the function over there, and then I'm going to put a little prime here. Now what does the little prime ask for? It says the local slope. Well, this is a line. The local slope of a line is just the slope, and so here I'm just getting m. So the right-hand side is nice and easy. The left-hand side's a mess, because the left-hand equation looks like 2x to the 1/3. If you're a math or physics major, you need to work that out. For the purpose of the test, I will be giving you the formula for the derivative of the messy side. You can see that in the problem. I'll write it right now. So I'm just now doing the left-hand side. I want LIM x arrow 4 minus, and then I want the icky derivative. Now the icky derivative here is going to be 1/3 times 2x to the minus 2/3 times 2. That is the formula for the derivative of the icky side, and that needs to be equals. If you're a math or physics major, you need to go work that out. Meanwhile, I have a limit to evaluate. I'm supposed to just plug in 4. So here we go. 2 times 4 is 8. 8 to the 1/3 is 2. 2 to the minus 2 is 1/4. So I'm going to get 1/3 times 1/4. That's a 12th. A 12th times 2 is a 6th. So I'm going to get 1/6. And 1/6 has to be equal to m. So what we saw in the first part, there were many different lines that we could draw that were going to be continuous, but there's only one possible slope that actually works. So what I'm going to do is I'm going to erase this, because you can watch this anytime you want, and I'm going to go write down our two conditions, pulling my other conditions from the refrigerator. So here was the condition we got from the refrigerator. It says 2 equals 4m plus b. That was the left-hand height, has to be the right-hand height. The second part we got from the left-hand slope being the right-hand slope, and we got 1/6 equals m. Now, these are two equations, two unknowns. I can certainly put 1/6 in for m into the second equation. So I get 2 equals 4/6 plus m, like that. 2 is 6/6. This is, 2 is 6/3. 6/3 minus 2/3 is 4/3. So I'm thinking that's right. In other words, there's only one slope, and yes. Did I do that wrong? This is supposed to be b. Boy, I like that better. Yay! Okay, we'll try that. One slope and one y-intercept that works. What that says, if I put this in here, so what do I want? I want 1/6 x, because this is a function, plus 4/3. And I draw this graph until x equals 4, and then 1/6 plus 4/3 after x equals 4 is supposed to be continuous and smooth. I'm thinking I tried to do this at Desmos. Let's just see if it's right. I have over here, I have 2x to the 1/3 from x is less than 4. That's what we were supposed to have. And then over here I have 1/6 x plus 4/3 for x is bigger than 4. And it's supposed to be smooth the whole time. Well, it's no surprise that it's smooth back here. That's just our power function. It's no surprise that it's smooth after here. It's just our line. All the work we did was right at 4. And you can see, by the way, that no matter how many times you zoom in at 4, it's going to be nice and smooth. And that's the whole problem.